Hi, I'm Amir Hossein Mirzabozorg, and in this video I want to talk about meshing complex biomechanical parts including bones and soft tissues in Abaqus Part 2. How to ask your video related questions. Don't hesitate to ask any questions you might have about the explanations presented in this video using the comments below. We try to answer all questions regarding the video details in the comments below. This is the table of content. I will talk about meshing the bone after defeaturing, setting Abaqus to use unmapped tetrahedral elements, first try for obtaining optimum mesh, visual inspection of generated elements, performing additional defeaturing by using manual defeaturing tools, using Verify Mesh tool for checking mesh quality, changing the mesh controls from unmapped to mapped, comparing the mesh patterns before and after defeaturing, and finally, I will talk about final advice for meshing complex 3D geometries. After removing extra edges from the complex imported geometry in the first part of this tutorial, the part is ready to be meshed. In the second part of this tutorial, the defeatured geometry will be meshed using the free meshing technique. In the following, the quality of the generated elements will be checked and additional modifications will be made on the geometry to obtain the optimum high quality mesh. In the previous video, I imported the solid geometry into Abaqus and I removed some of the extra features. In this tutorial, I mesh the modified geometry and then I will check the mesh quality and I will do the other remaining steps. Now I want to mesh the bone after defeaturing. I will use Global Seeds tool for generating seeds on all of the edges of the model. Approximate global size of the mesh must be selected according to the dimensions of the part and the length of the remaining edges. This should be determined by trial and error. And I will use the free meshing technique and I will mesh the geometry by using tetrahedral elements. And I will set Abaqus to generate unmapped mesh. Sometimes when it is set to map tetrahedral elements, more elements with low quality will be created. This is not desirable for complex geometries. And this is the result of our first try for generating an optimum mesh. Now I go to Abaqus CAE to generate this mesh. I go to Mesh module. I click on Seed Part and I set the approximate global size to 6 and click on Apply and then click on OK. Then I click on Assign Mesh Controls. I select Tet for element shape and the free meshing technique is selected automatically. Then I deselect this setting for generating unmapped tetrahedral elements and I click on OK. Now I click on Mesh Part and the 3D mesh is generated. This number of elements is created and the element name is C3D10, that is a quadratic tetrahedral element. Now I go back to the slides. Now I want to talk about visual inspection of generated elements. To generate a mesh with an optimum number of elements, we have to avoid regions with undesirable dense mesh or reduce the number of such regions. In this picture, I have specified two regions that include undesirable dense mesh. Now I must make some modifications to avoid these regions or reduce the number of them. Now I go back to Abaqus CAE. I want to show you these regions. This one and this one. Now I hide the native mesh. I must combine several surface partitions to avoid these regions. I will use virtual topology combine faces. I select these faces and combine them. And then I select these faces and combine them. Now I go back to the slides. In some complex geometries, more modifications must be made on the geometry. By using manual virtual topology tools, some remaining edges will be removed. I have already done this step, and I must combine these surface partitions. I go back to the Abaqus CAE to make this modification. I click on Virtual Topology Combine Faces. Now I go back to the slides. Now I want to introduce Verify Mesh tool. We use Verify Mesh tool for checking the mesh quality. By clicking on Highlight, some of the elements will be highlighted in yellow or purple. Yellow elements are low quality elements, and purple elements are badly distorted. Even there is one purple element in the model, the simulation will not be started and you will encounter error. In this picture, there is only one yellow element that has low quality. I go to Abaqus to check the mesh quality. As I have made some modifications on the geometry, I must remesh the part. I click on Mesh Part and click on Yes. And I show the native mesh. I click on Verify Mesh and I select the geometry and I click on Highlight. There are two low quality elements. I go back to the slides. To change the mesh module settings and generate a new mesh without removing the settings of the previous mesh, a copy from Model 1 is created and named Model 2. I go to Abaqus to create Model 2. I right-click on Model 1 and I click on Copy Model. And I name it Model 2. Model 2 is created. As mentioned before, to obtain an optimum mesh, several trial and error must be performed with changing the mesh controls and element size. In Model 2, I set Abaqus to generate mapped tetrahedral elements. I go to Abaqus to generate the new mesh. I click on Assign Mesh Controls. I select the geometry. And I activate this setting and click on OK. And I click on Mesh Part. The new mesh is created. I go back to the slides. In this picture, there are two low quality elements. Now I go back to the Abaqus CAE to check the quality of the new mesh. I click on Verify Mesh, I select the geometry and click on Highlight. There are several low quality elements in the model. This is the report of mesh quality check. I go back to the slides. For improving the mesh quality, also you can change the element size. Now I want to talk about final advice for meshing complex 3D geometries. Sometimes, because of the complexity of the geometry, we cannot obtain the mesh without any highlighted elements. In these cases, we must try to decrease the number of highlighted elements to obtain the available high-quality mesh. In the following tutorials, more tips and tricks will be presented for performing biomechanical simulations in Abaqus. You can contact me by using Telegram or WhatsApp, or you can send email to me. We can have one-on-one tutoring on the AnyDesk, WhatsApp, and make special tutorials to your order. We can perform high-quality simulations for your thesis, exercises, and industrial projects. Now, I want to suggest you several related videos of our YouTube channel. Thank you so much for watching this video. Have a good time. Goodbye.